These are the Geometry 7.5 video notes, part 1, which we will go all the way through everything about trapezoids. So on this prerequisite skills practice, it wants us to find the measures of angle 1 and angle 2. So right here on angle 1, I see that angle 1 and then this 60-degree angle right here. They are consecutive interior angles, like on two parallel lines cut by a transversal. They're consecutive interior or same side interior, which tells me that they are supplementary, meaning they add up to 180 degrees. So I can then solve for angle 1 and find out that angle 1 is 120 degrees. Now from there, to find angle 2, I can go ahead and I know that the three angles that we know are 120, 90, and 60 degrees, plus the fourth angle, angle 2, all together add up to the sum of a quadrilateral, so the sum of interior angles of any four-sided shape is 360 degrees. So from there, I can subtract the 120, the 90, and the 60, and I end up finding that angle 2 is 90 degrees. Okay. So properties of trapezoids. So a trapezoid is a quadrilateral, meaning four sides, with exactly one pair of parallel sides. Those parallel sides are called the bases. So the two sides that are parallel, each of them is called a base. You just have one of them's base 1 and the other one's base 2. And these are the sides that we know are parallel. So then we have the base angles. Base angles of a trapezoid are two consecutive angles, so like next to each other, whose common side is a base. So for example, you have angle A and angle D are base angles because they share the base as a common side. So A and B are not base angles because they share a leg as the common side. So you can see these arrows point to the base angles. So B and C are base angles and A and D are base angles. So the trapezoid has two pairs of base angles. Now, the non-parallel sides, so the two sides that are not parallel in the trapezoid, are called the legs of the trapezoid. All right, and if the legs of the trapezoid are congruent, meaning if they are the same length, if the two legs are congruent, then it is called an isosceles trapezoid. Okay, so this says show that ORST is a trapezoid. So to do that, we need to show, remember that to be a trapezoid, it will have one pair of parallel sides. All right, so if I can show the slope of RS, so the slope of RS, if we just count it, it's up 1 over 2, so 1/2. And the slope of OT is up 2 over 4, which is 1/2. So because they are parallel, because they are parallel, then what that tells us is that it is a trapezoid because it has one pair of parallel sides. Now technically we should probably also show that side RO is not parallel to ST, but I feel like that's obvious by looking. So ORST is a trapezoid because it has one pair of parallel sides. Now it also says, now decide if it is isosceles. So if it is isosceles, then the two legs are going to be congruent. So the distance from R to O, because it's vertical, we can just count it. So we know that the measurement of RO is 3. Now to find the measurement of this side from S to T, we need to use the distance formula. So remember that the distance formula is in the square root, and it's x2 minus x1 squared plus y2 minus y1 squared. And we can put that in a calculator, and I get the square root of 8. So the square root of 8 is not equal to the square root of, or to just 3. The square root of 8 is not 3. So it is not isosceles. They would have to be equal for it to be isosceles. All right, the isosceles trapezoid based angles theorem says that if the trapezoid is isosceles, meaning we know that it has the legs are congruent to each other, then each pair of base angles is also congruent. So what this means is if we know that trapezoid ABCD is isosceles, then we know angle A is congruent to angle D, and we know angle B is congruent to angle C. Now, the isosceles trapezoid base angles converse says if we know that the pair of base angles are congruent, then it is an isosceles trapezoid. So if we can prove that, for example, angle A is congruent to angle D, that is enough to prove that trapezoid ABCD is isosceles. Or we can use the other pair of base angles, which is if we know that angle B is congruent to angle C, then that is enough to prove that it is isosceles. Okay, and then the isosceles trapezoid diagonals theorem. It says that a trapezoid is isosceles if and only if its diagonals are congruent. So if the diagonal AC is the same length as the diagonal BD, then that is enough to prove that it is congruent. All right, this says Incan architecture often features trapezoidal doorways and windows. Find measure of angle M, measure of angle K, and measure of angle L in the doorway. All right, so what we see here is we have this trapezoid. I'm just going to kind of draw it so you can see it a little bit better. It shows us that KL is parallel to JM. It also shows us that the legs are congruent. So since the legs are congruent, we know that angle J, which is 85 degrees, is going to be congruent to angle M. So we know that the measure of angle M is also 85 degrees. Now the other thing I can do in a trapezoid, I know that just what we started off class with, is that these two angles, the ones that are along the leg, are going to be supplementary, meaning they add up to 180. So I know that angle J plus angle K equals 180 because they are consecutive interior or same side interior angles. So I know that 85 degrees plus angle K equals 180 degrees. And so that means that angle K must be 95 degrees if you subtract the 85. And then K is the same length as L because they are base angles. So angle L is also 95 degrees. All right, there's another special part of a trapezoid. It is called a mid-segment. So the mid-segment connects the midpoints of the trapezoid of their legs. So it is the mid-segment, and so it's taking a midpoint. You can see the two markings here, meaning that it cuts this side into two equal parts. And this midpoint, the marking here shows it cuts the right side into two equal parts. So the mid-segment of a trapezoid is parallel to each of the bases. So if these bases are parallel, the mid-segment is also parallel to each of them. We also know that its length is half the sum of the lengths of the bases. All right, and so what that means is that AB, the top base, is parallel to the mid-segment, MN, and that's also parallel to the bottom base, DC. And the mid-segment, MN, is half the sum of the bases. So base 1 is AB plus base 2 is DC. So you add them together and then you half it, and that's how long the mid-segment is. Okay, so it says in the diagram, MN is the mid-segment. Find MN. So MN is half the sum of the bases. One of the bases is 12, the other base is 28. So you add the bases first, so you'll do, or you can just put it in a calculator all at once, but you'll do 12 plus 28. That's going to get you 40. And then half of 40 is 20. And this was in inches. And that is the length of MN. All right, in the diagram, AB is 5.1. Let's label that. MN is 9.4. Find DC. So I'm going to call DC X. So I know that MN is half the top base plus the bottom base. So let's fill in what I know. MN is 9.4. That is half 5.1 plus X. All right, I can distribute the 1/2 into the parentheses, or I can go ahead and I can start by timesing by 2, because you can multiply by the reciprocal. 1/2 times 2 over 1 is just 1. That's why it essentially cancels out. That gives me 18.8 equals 5.1 plus X. I'm going to then subtract the 5.1, and that will then get me 13.7. So that means DC is going to be equal to 13.7 units. All right, this one wants us to find the length of mid-segment YZ in this trapezoid. So what we can do here is we can find the length of SV, and we're going to need to use the distance formula for that. So we're going to do x2 minus x1 squared plus y2 minus y1 squared. And so I can use a calculator to help me find that number. It ends up being the square root of 20. I'm just going to leave it like that instead of as the decimal. It's just easier to do math with later on. So I put this part in my calculator, everything under the square root, and I got the 20, and then I just write it as square root of 20. Now let's do the same thing for TU. All right, so we're going to have to do 8 minus 12 in parentheses squared plus 10 minus 2 in parentheses squared. I type in everything underneath the square root. I don't actually type in the square root, just all of this stuff, and I get 80. So that's the length of TU. So to find the mid-segment, I'm going to do half, and then in parentheses, the square root of 20 plus the square root of 80. Now, personally, I would just go in and type that in the calculator. All right, so here I just typed in my calculator, which is about 6.7. But if they did want it exact, then I would need to simplify my units. So the first thing I have to do is simplify 20. You can use the hockey stick method or the factor tree for that. So the square root of 20 ends up being 2 square root 5. And then I'd simplify 80. 2 times 20, 2 times 10, 2 times 5. All right, and then the square root of 80 ends up being 4 square root 5. So if I wanted an exact answer, I would have 2 square root 5 plus 4 square root of 5, which is 6 square root of 5. And then half of that, you take the half times the 6, and you get 3 square root 5. So it just depends on if they ask you for an approximate answer, but if they ask you for an exact answer, you're going to have to use simplifying radicals to finish that. As you can see right here, they add up to the 6.7 is exactly the same as 3 square root 5. It just depends on how the question asks you for your answer, whether it wants exact form or rounded to a certain decimal.